you can see that there are 3 statements and 2 conclusions. Our job is to find out which of these conclusions follow the given statements. Although directions have not been given here, you know what the instructions would be, right? Consider the given statements to be correct, even if they seem to be at variance from commonly known facts, and find out which of these conclusions can be logically deduced from the given statements. And the best way to solve such questions is to go by Venn diagrams. So the first statement here says all queens are beautiful. All queens are beautiful. So what do? Draw queens and beautiful in this format, right? This is the circle which represents queens, and here we have got beautiful. So all the queens are beautiful. Next statement, some princesses are queens. Some princesses are queens. So some princesses are queens. Remember, we draw the diagram in such a way that there is minimum encroachment, minimum overlapping, right? Try to follow that. That's what is basic diagram, right? Basic Venn diagram would mean the one where we have minimum encroachment, right? Least overlapping. So all queens are beautiful. Some princesses are queens. And the last one says no beautiful is royal. No beautiful is royal. So royal is here, and beautiful and royal cannot touch each other. I have put a cross mark on these 2 circles, means these 2 can never overlap with each other. All right, let us quickly run through the statements again. All queens are beautiful. Some princesses are queens, and no beautiful is royal. Now look at the conclusions. The first one here. All beautifuls which are princesses will necessarily be queens. All beautifuls which are princesses. All beautifuls which are princesses. So let us find out this region first in the diagram. All beautifuls which are princesses. I'll use a different color to highlight this, right? I mean, so that it's easier for you to follow, right? Let me just, I'm trying to highlight this part. All beautifuls which are princesses. Tell me the region there. All beautifuls which are princesses. This circle. You're able to follow? This shaded region is what we are referring to. All beautifuls which are princesses is this region. So it says all beautifuls which are princesses will necessarily be queens. Will necessarily be queens. Now, do you find all these to be queens? All beautifuls which are princesses. All beautifuls which are princesses. These are all the beautifuls which are princesses. Are they all queens? No. But the conclusion says that all of them will be queens. Will necessarily be queens means what? This green shaded region. Let's refer to it as green. Green will necessarily be queens. Green will necessarily be queens. Do you find green to be queens? All the green to be queens? No. He says green will necessarily be queens, but not all the greens are queens, right? Only some of them are queens. So all beautifuls which are princesses will necessarily be queens would be a wrong conclusion, because it fails in the basic diagram itself, right? This conclusion does not follow the basic diagram, right? This conclusion does not follow the basic diagram. Hence it is false. Do we have to verify the possible diagrams? No. We will go for verification of possible diagrams if and only if the conclusion has satisfied the basic diagram. Here the conclusion fails in the basic diagram itself. So we don't have to worry about that. Next conclusion. Next conclusion says all queens are royal. All queens are royal. Now at the very first glance you would know that the conclusion 2 here does not follow. Why do we say so? See, we have clearly indicated that royals and what is B here? Beautiful. Royals and beautiful will never overlap each other, right? A cross mark on these 2 sets indicate that these 2 will never overlap. Royals can never overlap with beautiful, which means royal cannot touch beautiful. If royals cannot touch beautiful, how can royals touch queen? Queens are completely guarded by beautiful, right? Queens is completely inside beautiful. Can queens grow bigger than beautiful? Not possible. Queens can at best be equal to beautiful. Queen and beautiful can be equal. Queen can be equal to beautiful. But can it be more than beautiful? No, it cannot be more than beautiful. So the point is, when queens cannot go outside and royals cannot come inside, how do you think all queens will be royal? Impossible. Not even a single queen would be royal. So all queens are royal is also wrong. So 1 does not follow, 2 also does not follow. Our conclusion should be none follows, or neither 1 nor 2 follows, right? Neither 1 nor 2 follows. And all those who have got option none follows as the answer are correct. What are the statements? All friends are girls. Some girls are not men. Some men are not teachers. So be careful. We have got some not type of statements here, right? All A's are B's. Some A's are B's. No A's B is common. But some A's are not B's as an uncommon statement type. So you have to be careful when you draw the basic diagram in such cases. Okay. So let's draw the basic diagram for the given statements. All friends are girls. All friends are girls, right? All the friends are girls. Then some girls are not men. Some girls are not men. While some A's are B's is drawn in this way, right? Girls here and men. Some girls are not men. Which girls are we talking about? Understand. Let me use a highlighter to show this to you, right? Here if you see, some girls are not men. This shaded region is shown by this region here, outside wala. Some girls are not men. So if you see, all these outside girls are not men. Right? The shaded region that we have here represents this statement here, right? Some girls are not men. Some girls are not men. So these outside girls are not men. So the point that you have to be careful about is whether the statement is some A's are B's or some A's are not B's. Some A's are B's or some A's are not B's. The diagram is the same, right? What's the diagram here? Let's say this is A and here is B. What's the diagram here? Same diagram, A, and here we've got B. But the difference is when we say some A's are B's, we are referring to this region, the shaded region here, right? And when we say some A's are not B's, we are referring to the outside region, right? The A's which are not B's, the A's which are not common with B's. All right. So be careful about that. Some girls are not men, we refer to the external region. And then the last statement here says some men are not teachers. Some men are not teachers. Let me draw it this way. Some men are not teachers. Again, if I have to use a highlighter here, just to show you what we are referring to, then some men are not teachers. Some men are not teachers. This particular region is represented by this area here. Some men are not teachers. So these outside men are not teachers. What does not overlap with teachers is the region that we are looking at, right? Some men are not teachers. So these outside men are not teachers. You're able to follow. Be very careful. Some not type of statements. So some men are not teachers. The outside men are not teachers. Now let's look at the conclusions, right? Only two conclusions. The first one here says some friends are not men. Some friends are not men. Well, this is the basic diagram, by the way, right? So if you look at the basic diagram, some friends are not men is correct, right? Some friends are not men. This friends, here we have got friends and here we have men, right? So some friends are not men. Some friends are not men. We can always choose some of these friends and say these are not men, right? All these friends are not men. We can take some portion of F and say these friends are not men. So basically this conclusion satisfies the basic diagram. Some friends are not men, it satisfies. However, if I draw a possible diagram, I can sense that it would fail. Let me show that to you, right? The possible diagram, right? Like for example, the first statement was all friends are girls. So we have drawn it in this way, all friends are girls. The second statement was some girls are not men. Now some girls are not men can also be drawn in this way. These outside girls are not men. Outside girls are not men. And then some men are not teachers. Some men are not teachers. Now if you look at this possible diagram, there is nothing that has been done against the statements, right? All friends are girls. All the friends are girls. Some girls are not men. So outside girls are not men, right? Some girls are not men. And some men are not teachers. Some men are not teachers. These outside men are not teachers. However, if you look at the overall diagram here, we find that all the friends have come inside men. You see, all the friends have become a portion of men. All the friends are inside men. And if all friends are men, if all friends are men is possible, right? All friends being men is possible, then how can we say some friends are not men? In this particular possible diagram, not even a single friend can be taken outside men. All the friends are men. All the friends are men. Hence, this conclusion, some friends are not men. Some friends are not men is false. Why is it false? It satisfies the basic diagram. Some friends are not men outside, right? Some friends are not men. It satisfies the basic diagram. But like you all know, just because a conclusion has satisfied the basic diagram does not mean that it is correct. You have to check the possible diagrams as well. And if I draw the diagram in this way, this is a possible diagram without violating any of the given statements, I find that all the friends become men. And if all the friends are men, we cannot say that some friends are not men, right? We cannot say that some friends are not men. Next statement, some teachers not being a girl is possibility. Now look at the basic diagram first. Some teachers not being a girl is a possibility. Well, yes, from the basic diagram itself, it is possible. Some teachers not being girls. I mean, I can say these teachers are not girls. These teachers are not girls, right? These teachers are not girls. You understand? We can take some portion of teachers here and say these teachers are not girls. It satisfies the basic diagram itself. Even if you draw the possible diagrams, you will find that some teachers are not girls. Like for example, here maybe we have drawn teachers in this way. Even if you draw teachers, let's say in a bigger, if you show teachers in a bigger circle, even then we find that the given conclusion follows. Like for example, the last statement was some men are not teachers. I can say some men are not teachers is drawn in this way. Now if you see, the statement says some teachers not being a girl is possible. Yes, these outside teachers are not girls. If you see, these outside teachers are not girls. Some teachers are girls, but the outside teachers are not girls. So some teachers not being girl is a possibility. Is it possible? Yes, it is possible. So we can say conclusion 2 follows. You're able to follow? So conclusion number 1 does not follow. Some friends are not men. Some friends are not men. Remember, satisfies the basic diagram, but when you check in the possible diagram, it fails. Conclusion number 2 satisfies not only the basic diagram, but also all the possible diagrams, because some teachers not being a girl is always possible. Some teachers not being girl is possible, right? It is a possibility type. The difference is the first conclusion was definite type. This was a definite type conclusion. So you have to check each and every diagram. But the second conclusion was possibility type. So you don't have to check every diagram, right? You can just check one of them and say whether it is possible or not possible. So overall answer to this question should be only 2 follows. Only 2 follows. Only conclusion 2 follows.